Alright, let's look at the homework 6.4, problem number 7. Alright, so this is another leaky bucket problem. Alright, this time the rope is heavy enough so we cannot ignore the weight of the rope. So we're going to split into bucket part and a rope part. So let's look at the bucket. Right, so it's a leaky bucket. It's a 10 kilogram to begin with. Then we have a 36 kilogram of water in it. So originally this is 46 kilogram. Alright, then it says that water leaks at the constant rate and it finishes draining just as the bucket reaches the 12-meter level. Right, so as you go to through 0 meter to 12 meter, it loses 36 kilogram of water. So 36 divided by 12, so it loses 3 kilogram per meter. Right, so if bucket is at the level of xi meter high, so it's xi meter high, then the weight of this thing is going to be 46 is the beginning weight, but it loses 3 kilograms per meter, so 3xi. Right, so that will be the weight. Right, so all you really have to do is so weight is of the bucket is 46 minus 3xi. Right, so that's the weight. Then if you multiply this weight by so it's a mass and acceleration, which is 9.8, so this is a g value, 9.8, so this will make it a force. Right, then we want to find the work required to, say, move delta x. So distance it moved, it would be delta x. Right, so that would be the work required to move a bucket delta x at the height of xi. Alright, how about the rope? Alright, rope part, we're going to look at the height of xi. Then we're going to look at the little piece, the length is delta x, and we want to find the work required to lift it to the 12-meter level. Right, so the density of the rope is 0.8 kilogram per meter. Right, so weight of just one piece here is going to be 0.8. Then multiply by delta x. Right, so that will be the weight, and of course we have to turn it into a force. So we multiply by 9.8. So that's the acceleration by the gravity. Right, and also we have to determine the distance it needs to travel to go all the way to the top. So since this is a piece at xi, to go up to 12-meter level, it would have to move 12 minus xi. Right, then we just, so this is the one piece, so we have to sum them up. So we can put the summation sign here. And to make it more precise, we can take the limit. Alright, so that was the idea. So let's clean it up a little bit. So 9.8 is in both terms. I'm going to pull that out. So this is going to be limit sum. I goes from 1 to n. Alright, so 9.8 is in common. So 9.8 is here and 9.8 is there. So I'm going to just put the 9.8 once. Right, and what's left would be, and also delta x is in common here and here. So I will write delta x right at the end. Right, then what's left is, let's see, here is 46 minus 3xi is there. And then I guess I have to distribute this 0.8 to 12 and xi, right? So 8 times 2 is 16, and 8 times 1 is 8, so it's a 9.6. So it's addition, and then you subtract 0.8 xi. Then we can combine these guys together, so you have a limit as n approaches infinity. Summation I goes from 1 to n, so you have a 9.8 times, right? I'm going to combine here 46 and 9.6, so that's going to give us 55.6 and a minus 3.8 xi delta x, right? So let's type this guy in. All right, so what we got was 9.8 times 55 point, I forgot what it was, 55.6 minus 3.8 xi, right? Then we can turn this into an integral. It's going to go from 0 to, of course, all the way up to 12. Then we just have 9.8 times 55.6 minus 3.8 x and dx, right? Then we want, let's see if we got this one correctly. So I'm going to submit for testing. Alright, I came back and looks like we got the first two parts correctly. Then we just have to evaluate the integral and round the answer to the nearest integer. Alright, so let's do that. Alright, so this is going to be just the integral from 0 to 12. Alright, we can put the 9.8 outside. Then you have a 55.6 minus 3.8 x dx. Alright, so 9.8 is there, and then antiderivative is 55.6 x minus 3.8 x squared over 2, going from 0 to 12. Right, so this is going to be 9.8. All right, so this is a little tedious here. So we're going to do 55.6 multiplied by 12, and 2 times 6 is 12, and 2 times 5 is 10. 2 times 5 is 10. Then you have a 5, 5, 6, 2, 7, 6, 6, and decimal point. So it's 667.2 minus, right? So this can be divided, so it's a 1.9, right? Then you have a 12 square is 144. So 144 times 1.9. 4 times 9 is 36, and another 36, so it's a 39, and a 1, 2, and 1, 4, 4, right? 6, and 3, and 7, and 2. Right, so this is a 273.6. So you have a 273.6 is subtracted. Alright, so it's going to be 6. So 6 minus 3 is 3. And then borrow 1, and it's going to be 9. And 5 minus 2 is 3. Right, so this is going to be 9.8 times 393.6. Right, then we multiply by, so it's a 9.8. Okay, So 6 times 8 is 48, right? 3 times 8, 24. Let's see, 24, so 28, and 72, 9 times 8, so that's 4, and 24, so it's 31, right? 9 times 6 is 54, 3 times 9, 27, and 9 times 9 is 81, right? And 3 times 9 is 27, so it's 35. Add them up. 8, 2, 7, and so that was it 1, so it's going to be 5, and 8, and 3. So you have decimal 2 decimal point, right? So round it to 3,857. Right, let's type it in. So so this is going to be about 3,857. Right, so let's type it in. 3,857. Right, so let's check, submit for testing. Alright, I came back and it looks like we got this one correctly. Right, so the computation was a little bit tedious, but we could get the right answer there. Alright, that's it. I hope that this was clear.